Hi, my name's Kevin Hind, and in this presentation, I want to look at the economic consequences of tariffs, and I want to show that in some measurable way. So in order to do that, I'm going to pose a question. So here's the question. First of all, we've got a country called Plentiful, and it operates under autarky, no trade, and it has the following demand for and supply of wheat. So what we have here is the quantity demanded of wheat, X, is 120,000 minus 20,000 PX, and the quantity supplied of wheat is equal to 20,000 PX, where price is in the price per tonne and Q is in tonnes per week. So the first question is, what is the equilibrium quantity and price in Plentiful under autarky? And then we're going to say, well, what happens if Plentiful joins the World Trade Organization, as many nations have, and then embraces free trade? And then it discovers that it can buy an infinite amount of wheat from other countries at a price of £1 a tonne. Then, of course, we've got to ask, what is the new quantity demanded and supplied? And then, what are the quantity of imports? Then we say, well, look, if Plentiful decides that it should raise a tariff of £1 on every import, what are the new level of domestic demand and supply, and how much will now be imported? And finally, I want you to illustrate on a diagram the welfare consequences of this tariff. Okay, so let's look at this particular question then. So here's the problem again. We have our demand curve and we have our supply curve. So the first question is, what is the equilibrium quantity and price in Plentiful under autarky? Well, what we know from our basic economics is that for equilibrium to occur, the quantity and price have to be in equilibrium. So the quantity demanded and the quantity supplied have to be in equilibrium. So Q dx is equal to QSX, and we just call that Q star. So 120,000 minus 20,000 PX, which is our demand function, equal to 20,000 PX, which is our supply function. A little bit of rearranging, 40,000 PX, and clearly what we've done there is added 20,000 PX to either side and then just rearranged it. 40,000 PX equal to 120,000, so clearly PX is equal to £3. Now we know that PX is £3. We can put that back, say, into the demand equation, right? So that's 120,000 minus 20,000 times 3, which makes that 60,000. So 120,000 minus 60,000 will leave us with a QDX of 60,000 tonnes. So in equilibrium, Q star, the equilibrium is 60,000 tonnes of wheat in equilibrium. So we know the price is £3 and the quantity demanded and supplied is 60,000 tonnes when we have autarky. So that was the first question. The next part of the problem was that Plentiful joins the World Trade Organization and embraces free trade. And it now discovers it can buy an infinite amount of wheat from other countries at a price of £1 per tonne. So what's the new quantity demanded and supplied? Well, what we do know is we know the demand curve, and we know that the price, in this particular case, the price is 1. So what would be the quantity demanded? Well, it'll be 120,000 minus 20,000 times 1, which is 20,000. So it equals 100,000 tonnes will be the new quantity demanded and supplied. And of course, by similar reasoning, the domestic quantity supplied will be 20,000, remembering that we know that QSX was equal to 20,000 PX. Okay, well, if P is 1, then clearly 20,000 times 1 is 20,000. So QSX, that's the domestic supply, is 20,000. That means, well, I hope you can see that we can see what the imports are, so that the imports are going to be 100,000 minus 20,000 equals 80,000 tonnes. So Plentiful at £1 a tonne will buy and sell 100,000 tonnes of wheat at that pound. 20,000 of those tons of wheat will be made up from domestic goods and domestic wheat production, and the other 80,000 will be imported. 80,000 tons will be imported. Okay, if Plentiful decides that it's going to raise a tariff of £1 on every import, what are the new level of domestic demand and supply, and how much is going to be imported? Well, what we know is now that the price has gone up from £1 to £2 because of the tax, the tariff on imports. And we know what the demand curve is, and we know what the supply curve is. So because we know that, when we put, for example, the £2 into the demand equation, QDX is 120,000 minus 20,000 times 2, which is 40,000. That leaves us with QDX equal to 80,000 tons. Similar reasoning gives us QSX is equal to 20,000 times 2, which is 40,000 tons. So there's domestic supply at 40,000 tons. Domestic demand is 80,000 tons. The only way we can meet the demand is through imports of the additional 40,000 tons. Finally, we were asked to illustrate this particular problem on a diagram and show the welfare consequences of the tariff. So what we could do is, if we were going to draw it diagrammatically, is work out the inverse demand and supply curves. After all, when we draw a demand and supply curve, the price is on the vertical axis and the quantity is on the horizontal axis, but we were given the problems in terms of Q as a function of P for both demand and supply. So we could have the demand curve like so, and become an inverse demand curve or implicit demand curve like so, just by rearranging, dividing through by 20,000. And likewise, we could do the same with the supply function here. So that would be the normal way of looking at the supply function, which is what we're given in the question, but we could make it as an inverse demand supply function, and P would become a function of QSX. Okay, but really we don't need to do that. I'm going to stick here with the normal supply and the normal demand curves, and recognize that the demand curve and the supply curve, when we draw them, have P on the vertical axis and quantity on the horizontal axis. And so here we have the particular diagram concerned. So here is price, here is quantity, here is our original demand curve, here's our original supply curve. So let's look at the demand curve very quickly to see how we get the autarky solution, no trade. If we look at the point where, let's say that price is 0, okay, so we went then that price was 0, what would be the quantity demanded? Well, something equals 120,000 minus 20,000 times 0, which is obviously 0, so QDX must be 120, and that's why this point here would be the case. We'd be at this point on the demand curve. Obviously, if this was 0, if QDX was 0, then all we'd need to do is divide the 120,000 by the 20,000 to get the PX, which would be 6. So we've got our 2 points. It's a linear demand curve, and so we could plot a various other points down here. On the supply curve, okay, there is no intercept value. Okay, so clearly when the price is 0, the quantity supplied is 0. We'll be down here. And we can then take a value for PX, let's say 3, and guess what? The quantity supply would be 60,000, because in order to get 3 times 20,000 would be 60,000. So that would give us that particular point on the supply curve. It just so happens, as we know from our calculations, that that point where demand equates with supply is the no trade, the autarky solution. Price would be 3, quantity bought and sold would be 60. If we can get our product, our wheat, from the rest of the world at £1 a piece, well, it's easy enough to put that in here, just to see what the quantity demanded would be, for example, is 120,000 minus 20,000 times 1, which is the price, and that would be 100,000. 120,000 minus 20,000 would be 100,000. That would be the quantity demanded at a price of 1. The quantity supplied, given that it's QSX equal 20,000 PX, well, clearly if the price is 1, then quantity supplied is going to be 20,000. So 20,000 times 1 is the 20,000. So there is our initial solution. We've got the equilibrium, quantity being supplied and purchased domestically is 100,000, and we get imports of the 80,000 and the domestic supply of 20,000, which is given by our function here. So what happens if the price goes up to £2 because there's a tariff? Okay, well, here we've got a value of 2. So we go back to this equation for the quantity demanded. So the quantity demanded is equal to 120,000 minus 20,000 times 2. Well, that's 40,000. 120,000 minus 40,000 is 80,000. So the quantity demanded at a price of 2 is 80,000. The quantity supplied, domestic supply that is, when the price is 2, is clearly 20,000 times 2 is 40,000. So there's a domestic supply. Imports then are 40,000. Domestic supply is 40,000. When we want to calculate the welfare loss, it's fairly straightforward. We can take it in chunks if you like. We know that what's happening is that consumer surplus was A, B, C, okay, and you could take that as the 5 times 100, okay, and then half it, so that would be 500 divided by 0.5, because it's obviously half of a rectangle there, if I went like that. Okay, it's half of a rectangle, it's a triangle, we know that. And that would be 250,000. And then you could say, well, it's A, the new consumer surplus with the tariff is A, D, E. So it's 4, the difference between 6 and 2, times 80,000. And then divide that by a half, because it's, again, a triangle. And that would be 160,000. So 250,000 minus 160,000 is 90,000. But we can see what the loss of welfare would be because it's the red trapezoid here. I want to quickly see it's £1 times 80. And then you've got this 20 times a pound, but it's half of that. So it's 10. So 80 and 10 is 90. So the welfare loss is 90,000. We can also work out the net welfare loss, work out the value of the tariff, and we can also work out the value of the extra supplier surplus, producer surplus, EFGC, and we can work out the value of the tariff as FHID, okay, 1 times 40,000 units sold, so it's 40,000, and you can get, again here, the extra producer surplus is 20,000 times 1, so that's 20,000, then half of that triangle from 20 to 40, which is 20 times 1, but half of that, so that's 10, so together that's 30,000, the extra producer surplus. But then there's the welfare loss associated with the tariff, because clearly now we're now getting this extra domestic supply, but it's from inefficient domestic sellers. We could get this particular product from overseas at £1 each, and we're paying more by allowing domestic suppliers to sell it, and they're protected by the tariff. So we can work out what that value of that triangle is. It's 20 times 1, but half of that because it's a triangle, so it's 10. And we can do the same for the welfare loss associated with the net loss of consumer surplus from the tariff. That would lead us to understand the fact that we'd also have a £10,000 loss of consumer surplus. So there's the loss, summing it up, the loss of consumer surplus overall, the tariff revenue, the producer surplus increases by 30,000, and the deadweight loss, which was the two triangles we just showed, which we'll just show you again. That's GFH and DIB, and they are 10,000 plus 10,000, and that's a £20,000. So that's the net loss from the tariff in this particular problem. Thanks very much for listening.